Hey everyone. All right, so today we're going to talk about 2.6, which is quadratic inequalities. So you've probably done inequalities before, like back in algebra class maybe, where you had like linear inequalities, where you had like x plus 7 is greater than 5, and you had to graph a solution to that, and you had to figure out the solution set for that. So we're going to do the same kind of thing, except now we're going to take it up a level and do it with quadratics. So here we go. A quadratic inequality is going to look very similar. It's going to be a similar process to solving and factoring and finding zeros for quadratics. That's all going to be included in this. It's also, if you really enjoy working with things where there's specific steps of what you do, it's your lucky day. We do have steps that we can use to solve these equations. So here we go. First example. We're going to start with something like x squared minus 3x minus 15 is greater than 3. All right. So just like when we go to factor a quadratic to find the zeros and stuff like that, we're going to start off the same way by getting the whole thing not equal to 0 because we're not using an equal sign right now, but getting the whole thing greater than or less than 0. So in a way, we're going to treat this like it's an equal sign, at least for a while. So step 1, make it greater than or less than 0. Get all the other numbers on the other side. So for this one, for us, it means that we're just going to subtract 3 from both sides. So that means that we end up with x squared minus 3x minus 18 is greater than 0. Great, that's exactly what we wanted, because the next step is to factor this thing. We're going to factor this side. So for this particular one, we're looking for things that multiply to negative 18 and add to negative 3. So we kind of go down our list of possible factors, like 1 and 18, but that's not going to add to negative 3. Or 2 and 9, but that also isn't going to add to negative 3. But 3 and 6, we can work with that because 3 times 6 is 18. But since we need it to be negative 18, we can go 3 and negative 6 because 3 and negative 6 also add to negative 3. So we're good there. So now we can write out our factored form. We should have x minus 3 and x plus 6. Or sorry, goodness, other way around. X plus 3, x minus 6. Good grief. Okay, there we go. Greater than 0. Right there. Okay. Anyways, so now we have our factored form of this, x plus 3, x minus 6. The next step is to find the zeros. All right. So the easy way to find the zeros here is just to, you can either set each of these individually equal to 0, or you can think about what would make it 0 if I plugged it in for x. So in this case, if I wanted to go through and set them each individually equal to 0, x plus 3 equals 0. We subtract 3 on both sides, we get that x is negative 3. X minus 6 equals 0. We add 6 to both sides, and then we get that x equals 6. Okay. So in the next step, we're going to use both of those things because what we're going to do is set up our number line, and we're going to make a sign chart with it. So step 4, make a number line with your zeros that we just found. So we're going to set up our number line here. I need to have negative 3, and I need to have positive 6 on it. Because what we're going to do is we're going to figure out what's going to be part of our solution set here for this problem. Is it going to be the stuff in between those numbers? Is it going to be the stuff that's less than -3 or greater than +6? What's all going to be part of our solution? So what we want to do is, now that we have our number line, recall up here that this was what we had that was greater than 0. We're going to call x squared minus 3x minus 18. We're going to call that f of x. So f of x, our function, is x squared minus 3x minus 18. And what I want to do is plug in different values for x that are either less than -3 or in between -3 and 6 or greater than 6 to see if those end up being greater than or less than 0. So for less than something that's less than -3, we could go x is -4. We could try that and see what f of -4 would be. So let's do that. Let's grab our calculators here. And I'm going to plug, or I'm going to substitute -4 in for x in this equation. So we're going to go -4 squared. Always put your negative numbers in parentheses when you square them in the calculator. And then it was minus 3 times -4 minus 18. And we get 10. There it is, 10. Okay, so we know that f of -4 is +10. So the important part about that is if it's a positive or a negative number. In this case, 10 is positive. It's greater than 0. So we want to make a note of that. But the things that we plug in when they're less than -3 are going to be positive function values. So now we're going to try something in between -3 and +6. I'm going to try x equals 0. Because whenever you can plug in 0, that's an easy one to do. So we'll do that one. We'll find f of 0. And if I put 0 in for x in both of these places, we get 0 minus 0 minus 18, which is just -18, which tells us that when we substitute values for x that are between -3 and 6, we get negative numbers. And now I'm going to do the same thing, but I'm going to plug in, let's go with like x equals 10 or something. Just anything that's nice, a nice value that's greater than 6. So we're going to do f of 10. If you wanted to, you could do f of 6.5 or f of 7.375 or f of 100. Anything that's greater than 6 is fine, but 10 is usually an easy number to work with. So we're going to do the same thing again. Just like we did with -4, we're going to go 10 squared minus 3 times 10 minus 18. And we get 52. So f of 10 is 52, which is a positive number. So we're going to make a note of that. Okay. So now that we've made our number line with our zeros and our sign chart and all of that, and we figured out that these are positive, these function values are negative, and these function values are positive, the last thing that we need to do is figure out our solution intervals. Okay, so we know that we needed, from step 1, x squared minus 3x minus 18 to be greater than 0. So we want the intervals in our solution that are greater than 0, that produce function values that are greater than 0. So that means we need to have positive function values. So that means, according to our sign chart, that we want x values that are less than -3, and we also want x values that are greater than 6. So if we were writing that, let's see, if we were writing that out as an inequality, we'd say we want x's to be less than -3, and we want x's to be greater than +6. If we were doing this with our interval notation, though, we would say that that is the interval -infinity to -3, union with the interval 6 to +infinity. So that's how we're typically going to write our solution intervals. You could also express your solution using a number line. So I'm going to show that as well. So if we drew up another number line real quick here with -3 and +6 on it, I want numbers for my solution that are less than -3. So I put an open dot since it's strictly less than. It's not a less than or equal to. And then I draw an arrow going to the left. And then I want values that are greater than 6. So I put an open dot on 6, and I draw an arrow going to the right. And that's how we graph our solution set if we were asked to graph it. So there's 3 different ways we can express our solution. We can use inequalities, we can use intervals, and we can use graphing it on a number line. Typically, the one you're going to be asked for, though, is this one. Okay, so that's one example of quadratic inequality. Let's do another one. And I'm just going to actually divide this page in half, since we only really used about half the page anyway. So for example 2, here we go. This time, we're going to step it up just a little bit. The one we're going to solve this time is x minus 4, the quantity squared, is greater than or equal to 4. Okay, so remember, when you square a quantity like x minus 4, you really have to actually write out x minus 4 times x minus 4 and do the distributive property twice. So we're going to do that real quick. X times x is x squared. X times -4 is minus 4x. -4 times x is also minus 4x. -4 times -4 is positive 16. And it's still greater than or equal to 4. So now we have to combine some like terms. We also have to do step 1, which is making our function greater than or less than 0. So we want to move everything over to one side. So I know that we're going to have x squared and then minus 8x over here because -4 minus 4 is -8. But I'm also going to subtract 4 from both sides here. 16 minus 4 is 12. And now we have that it's greater than or equal to 0. Okay. So now we can move on to the step where we factor it. So we're looking for things that multiply to 12 and add to -8. So that when we write our factors out like this, we're going to have x in the front of each of them. And then we have, let's see, 12. Well, 2 times 6 is 12, and 2 plus 6 is 8. But since we want -8, we can go x minus 2, x minus 6. So that works for factoring it. So now that we factored it, that was step 2. Now we want to find our zeros. That was step 3. So what's going to make this 0? Well, x minus 2 equals 0 tells me that x is going to be positive 2. X minus 6 equals 0 tells me that x is going to be positive 6. So 2 and 6 are my 2 numbers that I'm interested in. So now we've got to make our sign chart, because that's our next step. Make the number line with the zeros, figure out the positives and negatives and all that stuff. So we have 2 and we have 6 on our number line. Move it up just a little bit. And our function was from back up here. We have f of x this time is x squared minus 8x plus 12. Okay, so I need to try out a value that's less than 2. So a value that's less than 2 that's easy to try out is 0. Let's see what happens when x is 0. So if I plug in 0, we get 0 squared minus 0 plus 12. So f of 0 is 12, which is a positive number. Cool. All right. Then I need to check a number that's between 2 and 6. Any number between 2 and 6 is fine. I'm just going to check x equals 3. F of 3, well, we got 3 squared is 9. Let's just grab a calculator, actually, because that's probably how most of you will do it. We'll go 3 squared minus 8 times 3 plus 12. And we get -3. All right, so that means that numbers between 2 and 6 give us a negative number for our function. And then lastly, we're going to try something that's greater than 6. So greater than 6, we're just going to go with 10 again, because that's an easy one to do. So if x is 10, we want f of 10. That means we have to do 10 squared minus 8 times 10 plus 12. And when we do that, we get 32, which is also positive. All right. So now that we want to figure out our solution set, we know that this function has to be greater than or equal to 0. So we want the positive numbers again. But this time, since we have this or equal to here, when I go to graph my solution, or when I go to find my solution as an interval, I need to make sure that I include my endpoints of 2 and 6. So here we go. I know that I want my numbers to be less than or equal to 2. So that's going to be for my interval -infinity to 2, but inclusive on the 2 side this time, since it's less than or greater than or equal to here, 0. Union with 6 up to +infinity, inclusive on the 6 side. The other way that we can do this to start with is graphing our solution set as well on a number line. So I can put 2 and 6 on the number line. And then since this is a greater than or equal to that we have, I can do a solid dot and an arrow, and a solid dot and an arrow. Okay. So there's a couple different examples of some quadratic inequalities that you might be asked to solve. We're going to do a couple more. We're going to have a kind of a two-part example for this next one. What happens if you end up with something that you can't factor? What happens if you end up with non-real solutions? So let's give it a go. All right, so for this one, I'm going to call it example, we're going to call it 3A. Okay, so this time we're going to try x squared plus 5x plus 8 is less than 0. So this one starts off with the first step done for us. It's already less than 0, right? It's already got the 0 part figured out for us. With this one, though, it's not one that I can factor easily. Like, it's not something that I can think of things that multiply to 8 and add to 5 and we're good to go. Doesn't work. So in this case, we're going to use the quadratic formula. So let's bust out the quadratic formula here. Reminding us of that, it's -b plus or minus the square root of b squared minus 4ac all over 2a. And remember, a is the number in front of the x squared. So in this case, it's an implied 1, so a is 1. B is the number in front of x there. And then c is the final term, the constant. C is 8. Okay, so now let's go ahead and plug those into the quadratic formula. So -b means -5 plus or minus the square root of b squared, so 5 squared, which is 25, minus 4 times 1 times 8, since that's a and c, all over 2 times a, which was 1. All right, well, 4 times 1 times 8 is 32. So we get -5 plus or minus the square root of 25 minus 32 is -7. All over 2. Well, that's a problem. because 5 or -5 plus or minus the square root of -7 is going to give us a non-real solution. It's going to give us complex numbers for our answer. And we can't really graph that on the real number line, right? So here's what happens. First of all, this is going to be one that has no real solutions. Second of all, what happens when you go and graph this quadratic is you end up with something that looks like this. And is that function ever less than 0? No, it's not down here at all, is it? It's never less than 0. So for that reason, this has no real solutions because this function is always greater than 0. So when you end up with no real solutions or no real zeros, you need to check what the graph looks like and see if the function is always greater than 0 or is it always less than 0. So I'm going to show you another case. So this is going to be example 3b. And you'll see how these are related because we're going to use the same exact problem. X squared plus 5x plus 8. Except this time we're going to say it's greater than or equal to 0. So it's the same problem. There's still no real zeros. But this time we look at the graph. And we notice that it looks something like this. And it's still, the function is always greater than 0. So this statement is always true no matter what I plug in for x, right? So that means that the solution to this one is all real numbers, because any number I plug in for x is going to give me a value that's greater than or equal to 0. So my solution is -infinity to +infinity, or all real numbers. So even though it has no real zeros, you can still have a solution that's different based on whether we want this thing to be greater than 0 or less than 0. Less than 0, no real solutions, because no matter what I plug in for x, I'm never going to have a function value less than 0 because the graph is all above the x-axis. But on this one, if I want it to be greater than or equal to 0, anything I plug in for x is going to give me a value greater than or equal to 0. So all real numbers is my solution. Okay. That's the only somewhat confusing case that we might run into there, because a lot of people are tempted to say, if there's no real zeros, there mustn't be a real solution, which is sometimes true, but also, as in the case of 3b, not always true. Okay. One more. This time I want you guys to try on your own before I show it. So for this one, we're going to go x squared plus 5x plus 6 is less than 20. So pause the video where you're at, give this one a try, and then restart the video, and I'll show how to get the solution so you can check your answer. Okay. Hopefully you paused the video for a moment, gave it a try, looked through your notes, kind of compared the process, because now I'm going to show how this one would be done. So subtract 20 from both sides to start with so that we end up with a 0 over here, so that we get x squared plus 5x minus 14 is less than 0. Keep in mind this time we want solutions to be less than 0. That's going to be something we need to kind of store away for later. We want negative number solutions. Okay, anyways, now we have to factor this thing. So factoring here things that multiply to -14 and add to 5, we're going to get x plus 7, x minus 2. Then we make our number line, or our sign chart here. We have For our zeros here, we should have -7, because if I plugged in -7 here, we get 0. And then 2 would be our other one, because if I stuck 2 in for x here, we'd also get 0. So then we're going to try different values into this equation here. So f of x equals x squared plus 5x minus 14. Trying different values in there. I need something less than 7, or sorry, less than -7. So I'm going to try x is -10 and see what we get. You might have tried something else. As long as it's something less than -7, you're good. So if I stick -10 in, we can go -10 squared plus 5 times -10 minus 14. When we do that, we get 36, which is a positive number. Yeah, that works. All right. Then we're going to do the same thing. And then we'll note that that's positive. And then we're going to do the same thing with something in between -7 and 2. So let's try x equals 0, since that's in between those. F of 0 is -14. So if I plug in 0, we get 0 plus 0 minus 14. So that's negative. And then finally, something greater than 2, I'm just going to go with 3. So f of 3 squared plus 5 times 3 minus 14 gives us 10. So then that's a positive number. We know that that's positive. And then we have to make our solution set. So note that this time we want less than 0 solutions. So we want our negative numbers, and our f is negative only between -7 and 2. So this time our solution is going to be from -7 to +2. We can also graph it on the number line if we want to. We can graph our solution as -7 and 2. It's going to be open dots, since it's a strictly less than, not a less than or equal to. We'll put an open dot on -7 and an open dot on 2. And then we want solutions in between those values, so I'm going to just connect that there. Okay, so that was quadratic inequalities. Hopefully that was helpful. I'll be back Monday, so feel free to ask if you have questions then. Otherwise, get to your assignment. You've got this. Have fun.